Morning students. Good morning students and welcome to the chemistry lecture for PUC second year. So as per the government declaration you have cleared the PUC first year and now you are enrolled in the PUC second year, and from today onwards we are starting our chemistry syllabus for PUC second. So in the introduction part only I'm going to introduce you the blueprint for the chemistry paper, the mark distribution, the lectures required for the each and every topic, and the patterns of question which is asked in the annual examination. Apart from that, we are going to discuss the uh, what are the different chapters which are present in the chemistry, and what is the content of that particular chapter, what points we are going to clear in that particular chapter, that we will going to discuss in this today's lecture. So we are starting the syllabus in very early, so as to help you for the study, and you will get the maximum time to clear the ideas, to study more and score the good marks in the second PUC. So we will start the lecture. So welcome once again, and this is for the mark distribution and syllabus for the chemistry is. So if you go through this table, you will find that what is actually what is the first column is the groups of chemistry, that the chemistry syllabus consists the topics, 5 topics from the physical chemistry, then the 4 topics from the inorganic chemistry, and the 7 topic from the organic chemistry. So total there are 16 topics in chemistry syllabus, and there are 2 parts of book. Part 1 consists 9 topics and part 2 consists 7 topics. The first topic from this syllabus, it is from part first, it is solid state, which has 8 number of lectures and 7 marks weightage for this topic, and they may ask question for 2 marks in the part B and 5 marks question in the question number 4 or part D. Then the second chapter from part first, it is solution, which has 9 periods time and 8 mark weightage, and here the questions, there are 2 questions for 1 mark and 1 question for 5 marks. Once again, the weightage of this topic is total 7 marks. So 7 to 8 mark weightage is there for the topic solution. Then the third chapter, which is electrochemistry, which has 9 periods the time and 8 mark weightage, and it has a question in the part A, part B, that is 1 mark question there is there, 2 mark question is there, and another one 5 mark question is there. So total 8 mark weightage. Fourth topic, it is chemical kinetics, which has 9 periods for teaching purpose, and it has once again 8 mark weightage, which has the questions in the 1 mark first A part, then there is a question for 2 marks, there is a question for 5 marks. On the fifth topic, that is surface chemistry, which has 6 lectures and 5 marks weightage, and the question comes in the 1 mark question also, 1 question, and in the 5 mark question. So total weightage is 6 marks. So the part first or group first, which has physical chemistry, the total weightage of this physical chemistry part is 36 marks. 36 marks. Then the sixth topic, which is general principle and process of isolation of elements, which is 5 period topic and 4 marks weightage. So it has a question for 1 mark, one question, and the question in the section C, that is 3 mark question. Total weightage is 4 marks. Then the next one, it is P block element. Here the topic has 11 lecture time and 10 mark weightage, and it is a question in the question number 1, that is part A, 1 mark question, and there are 3 questions in the part C, 3 mark question, and the total weightage is 10. So this is the topic which has highest weightage in the chemistry subject, which is P block element. So here what we are going to learn, we will discuss in the contents. Then the chapter number 8 is D block element, which has 9 lecture time span and 8 mark weightage. It is the question comes in the part B, that is 2 mark question, 1 question, and 2 question for 3 marks. So total weightage is 8 marks. And the ninth topic is from the part first. It has coordination chemistry, 7 lectures time span and 6 mark weightage, and 2 questions in the part C, that is 3 mark question. Total weightage is 6 marks. So this group second, which is nothing but the inorganic chemistry part, which has 4 topics and total weightage is 28 marks. The 10th topic, or we can say the first topic from the part second. Okay, so this is first topic from the part second book, which is haloalkane and haloarenes, 7 lecture time and 6 mark weightage. 1 question for 1 mark and 1 question for 5 marks. Total weightage is 6 marks. Second topic from part second, it is alcohol, phenol and ethers. 8 lecture topic, 7 mark weightage. Question in the 2 mark question, 1 question in the 2 marks, 1 question for 5 marks. So total weightage is 7 marks. The third chapter from the part second, it is aldehyde, ketone and carboxylic acid. It has 9 lecture time span and 8 mark weightage. 1 question for 1 mark, 1 question for 2 mark, 1 question for 5 marks. Total weightage is 8 marks. Then the next topic, it is amine, which has 6 lecture and 5 marks weightage. And question come in the 5 mark question only. There is no 1 mark, 2 mark or 3 mark question. Directly 5 mark question. So weightage is 5 marks. The next topic is biomolecules. Biomolecule has 7 lectures and 6 mark weightage. 1 question in the 1 mark question and 1 question in the 5 marks. Total it is 6 marks weightage. Next, the topic is polymer, which has 5 lectures and 5 marks weightage. Question comes in the 5 mark question, part D, last part, or the 5th question. And the 16th topic, last topic from this part second, it is chemistry in everyday life, which has 5 lectures and 4 mark weightage. 2 questions for 2 marks. Total weightage is 4 marks. And the group third, or the part second book, which has weightage of 41 marks. And if we look at the total, it is 105. So we have 105 marks question. Out of that, we have to solve 70 marks question. Okay, so maximum marks is 105. and 120 lectures we have to complete this 16 chapters. So this what I have discussed, the pattern, a blueprint of a question paper. This is for complete 100% syllabus. This is not for the reduced syllabus which is reduced during this corona period. So this is what the pattern, the blueprint for the question paper, model question paper for 2020 or 2020, March 2020 question paper. This the that question was like this only. Okay, so go through this, you will understood the pattern of questions and which topic, for which topic, where the question is coming, and how to calculate the marks, how to learn the concepts, on which area we have to focus, and go through the previous year question paper. You will get the idea that which particular concepts from the individual topics they are asked. Okay, now we will discuss the topics one by one, so as to get clear idea about what is syllabus we have. So the contents for the first book of chemistry is the first unit or the first topic. It has a solid state. What we are going to learn in this particular chapter, we are going to learn about the general characteristics of solid. So the characteristics of liquid and gases we have completed in the PUC first year. The name of topic is states of matter. In that particular topic we have discussed about the gas and liquid, and in the PUC second year we are going to discuss about this solid, the third state of matter. So general properties of solid we are going to discuss. Then we are going to discuss the types of solid, which we call it as amorphous and crystalline solid. So amorphous and crystalline solid, how to differentiate between them, we have learned during the salt analysis in the practical labs. Okay, so whichever is smooth uh, when we rub in the fingers, that is we call that it as a amorphous, and whichever is rough we call it as a crystalline. That what we have learned in the lab. That amorphous and crystalline solid we are going to discuss in detail in the theory. So in this particular we are going to learn in the amorphous and crystalline solid point, we are going to learn about the properties of amorphous solid, the properties of crystalline solid. Then we are going to learn about the what is the difference between these two types of solids. Then we are going to learn about anisotropy and isotropy. Okay, which one is showing isotropic and which one is going to show the anisotropy. Then in this topic we are going to learn about the classification of crystalline solid. We are not going to learn about the amorphous solid. The next part is totally for the crystalline solid only. So classification of crystalline solid. Crystalline solids are classified into different categories depending upon the type of interaction present between the constituent particle. So they are classified into different categories like ionic solid, covalent solid, then metallic solid, and molecular solids. So this classification we are going to learn in this point. Then we are going to learn about the structure of crystal, what we call as crystal lattice and unit cells. So the three-dimensional arrangement of different particles, constituent particle, what we call it as a crystal lattice, and the smallest representing unit of that crystal lattice is called as unit cell. So we are going to learn about the structure of crystal lattice also. We are going to learn about the unit cell also, the smallest part. Then we are going to uh, learn about the different types of unit cells, and in the different types of unit cells, what is the actual number of atoms present in each unit cell we are going to learn, we are going to calculate over here. Then we are going to learn about how the packing is, how the particles are placed in the crystal structure or solid, what we learn under point close packed structures. So how the structures forms we are going to learn over here. Then by learning the structure we are going to calculate the packing efficiency. So how much part of the particular unit cell is occupied and how much part is unoccupied we are going to calculate over here. And here we are going to learn about the packing efficiency of three unit cell, that is simple unit cell, then face centered unit cell or cubic close packed unit cell, and the third one is body centered unit cell. So for in the packing efficiency point we are going to learn about the calculation of three packing efficiencies or three different types of unit cells. Then we are going to calculate the dimensions of unit cells. We are going to learn about how to calculate the radius of sphere. We are going to learn about how to calculate the edge length of unit cell. We are going to calculate the density of unit cell. These calculations come under this point. Then the point comes that imperfections or the defects. So while forming the crystalline solid, there is a chance that solids may be imperfect or there is a chance of impurities. The impurities causes certain defects, what we are going to learn in this point. Then we are going to learn about the electrical properties, the conductor, insulator and semiconductors. Then we are going to learn about the magnetic properties of solids, that they are attracted by magnet or they are repelled by magnet, that we are going to learn in this magnetic properties. So here we are going to learn about the ferromagnetic, ferrimagnetic, antiferromagnetic substances, paramagnetic substances and diamagnetic substances. So these things come under the chapter number 1, what is called as solid state. In the second topic, what the name is solution. So solution is nothing but a homogeneous mixture of two or more components, which is called as a solution. So in this particular topic we are going to learn about the different types of solutions. So when two components, either it may be solid, liquid or gas, when they are mixed with each other, what kind of solutions they are going to form, that we are going to learn in this particular point, that is called as type of solutions. Then the expression of concentration of solution. Once again we are going to learn about the molarity, mole fraction, parts per million, and the mass by mass, volume by volume and mass by volume representation of solution. The next point we are going to learn about the solubility, and in this particular we are going to learn about the solubility of gas in the liquid, the solubility of solid in the liquid, and what is the effect of change in temperature and pressure on the solubility of gas and solid liquids in the solutions, that what we are going to learn over here. Then the vapor pressure of liquid solutions. Here we are going to discuss two important laws. One is Raoult's law. Then we are going to take a reference of Dalton's law, what we have studied in the state of matter over here, and the very important law, what is called as a Henry's law, we are going to learn over here, and the vapor pressure of liquid. Then we are going to learn about the ideal and non-ideal solutions and its equation. So we are going to discuss about the properties of ideal solution and non-ideal solutions, then the deviations from the Raoult's law, how the positive deviations and negative, which kinds of solution shows the positive deviation, which kinds of solutions gives the negative deviations, and what are the reasons for this particular deviations are, we are going to learn in this point. Then we are going to learn about the four different properties, colligative properties, and determination of molecular masses. So here we are going to learn about the lowering of vapor pressure, elevation of boiling point, depression in freezing point, and osmotic pressure. We are going to learn in the point, and by using that elevation, depression or osmotic pressure and the lowering of vapor pressure, we are going to calculate the molecular mass of solute which is present in the solution. And finally we are going to know about the abnormal molar masses, and in this we are going to learn about the Van Top factor. Okay, so some of the solutions, what we are for that solution, what we are calculating the molar masses by using these colligative properties that are different. And why the difference is, that is due to the association or the due to the dissociation of solute, and what the causes are, we are going to learn over here in this particular point, which is known as abnormal molar masses. Then the next topic, the next chapter is electrochemistry, and in the electrochemistry we are going to learn about the ideas which gives us the to produce the electricity or to generate the electricity by using the energy which is evolved in the chemical reactions. Or we are going to learn the some reactions are carried out by the means of electricity, or the reactions which are carried out by using the electricity, what we are going to learn over here. So here we are referring the topic what is known as redox reaction from the first year. So in the first point, the electrochemical cell, the cells which are used, or the devices which are used to convert the chemical energy to electrical energy, to convert the chemical energy to electrical energy, are called as electrochemical cells. So we are going to learn about this electrochemical cells and galvanic cells. Then the Nernst's equation, we are going to learn about the Nernst's equation which is applicable for the electrochemical cells. Then the conductance of electrolytic solutions, so ionic compounds in the liquid phase or in the aqueous phase or in the molten phase, they are good conductor of electricity. So how the conductance take place, how the electrolytic solution, why electrolytic solutions are good conductors, we are going to learn about that. Here we are going to learn about the conductivity, the resistivity of solutions, and we are going to determine the cell constant for the cell. So these ideas we are going to learn in the conductance of electrolytic solutions. Then we are going to learn about some electrolytic cells. So electrolytic cells in which the electrical energy is used to carry out the reaction, chemical reactions. So here we are going to learn about how to construct the electrochemical cells, and what is electrolysis, what is the product actually, when the electricity is passed through the solution, what happened with that solution particular, and which kind of products are obtained, what we are going to learn in this particular point. Then the next point is batteries. So we are using in daily life different kinds of batteries. The cell phone what I am using for the recording for this video, it has a battery. The torches what we are using in the home, that has the batteries. The watches, the different electronic devices, they has the batteries. So we are going to learn about the construction, working, the reactions involved in the particular batteries, and the voltage what they have giving, that we are going to learn. The in the batteries we are going to learn about the primary and secondary batteries, or dischargeable and rechargeable batteries. Then the next point is fuel cell. So we are going to learn about the construction and working, reactions, electrode reactions of the fuel cells. And finally we are going to learn the point corrosion in this topic, and the reaction taking place, the electrochemical reaction taking place during the corrosion of iron or the corrosion of metal. We are going to learn, and how to protect the metal from the corrosion, that we are going to learn in this particular topic. The next topic from the part first is the fourth topic, which is called as chemical kinetics. And in this chemical kinetics we are going to learn about the rate of chemical reaction, or the speed or velocity of chemical reactions, and the factors affecting on the rate of reactions. Then the integrated rate equation for the reactions, the order and molecularity of reactions, the temperature dependence of the rate of reaction, collision theory of chemical reactions. So here in this topic we are going to learn about the in the PUC first level we are going to learn about the zero order reaction and first order reaction, the half lifetime of reactions, first order reaction and zero order reactions, the units for the rate constant of first order, zero order and second order reactions. So there are total four derivations for the two for first order and two for zero order reaction, which are important, that we are going to learn how to derive the rate constant equation, and the half lifetime of the first order and zero order reactions, and the collision theory. In that collision theory we are going to learn about what are the factors which affects the rate of reactions, chemical reactions, that we are going to learn in this topic. This is the fourth topic from the part first. Then the fifth topic, what is called as the surface chemistry. And in this surface chemistry we are going to learn about the ideas of absorption and adsorption. Then we are going to learn about detail in the adsorption part. Absorption we are not going to learn because its our topic name is surface chemistry. So whatever things which are take place on the surface we are going to learn. So we are going to learn about the adsorption, the physical adsorption and chemical adsorption, then the difference between physical and chemical adsorption, the catalysis, the homogeneous and heterogeneous catalysis. Then we are going to learn about the colloids, the classification of colloids, the preparation of different types of colloids, and this purification of colloids, then emulsions, and the colloids around us, what kind of colloids which are present around us, that we are going to learn. So this is the part what we call as the group first as physical chemistry. So this physical chemistry has total 5 topics, and these 5 topics what we have discussed, we are going to learn these many points in this particular part. So in the part first, the next topic is from the inorganic chemistry and its general principle and processes for the isolation of elements. So we are going to learn about how the elements are extracted from the ores or minerals. First, what we are going to learn about the occurrence of metal. Here we are going to learn about the ore and mineral. What is the main difference between mineral and ore? We are going to learn over here. And the ores which has a maximum percentage of metal, they are used for extraction. So we are going to learn about how the ores are concentrated, how the unrequired part is removed from the ores, whatever material coming from the mining, how they are concentrated to get a metal. That we are going to learn in the second point, that is called as a concentration of ore. Then in the next point we are going to learn about extraction of metal from the concentrated ore. So here we are going to learn about the extraction of iron, copper, zinc, these three metals. So blast furnace, then roasting, and these things we are going to learn in this particular point. Then the thermodynamic principle of metallurgy and electrochemical principle of metallurgy we are going to learn. So at what temperature, what kind of products are formed, and how they are extracted, how metal is extracted, which metal is extracted at what temperature, that we are going to learn over here. Why the particular ore is required calcination, and why the particular metal ore is required the roasting, which kind of impurities can be removed at what temperature. That is nothing but the thermodynamic principle. And some metals are extracted by electrochemical methods, what we have learned in the electrochemistry, that is the electrolysis, what we are saying that. So how the electrochemistry is used in the metallurgy, in the isolation of elements, isolation of metal, that we are going to learn over here. Then the oxidation reduction. So some ores are oxidized then reduced, or some oxides are reduced to get a metal, that we are going to learn over here in this point, particular oxidation reduction. Then what kind the whatever crude metal we are extracted from the concentrated ore, how they get refined, because we are using the pure metals for various purposes. So various metals are purified by different methods, and what are the methods, particular methods used for different elements, that we are going to learn over here in the refining part. And finally we are going to learn about the uses of aluminum, copper, zinc and iron, these particular metals where we are using these, the application of particular metals we are going to learn in this particular topic. So extraction, that purification, and the use applications we are going to learn in this particular chapter. Next topic from the inorganic chemistry part, and the part first book, it's the p block elements. So in the first year syllabus we have the topic the p block element, which consists two groups from the p block, that is group number 13 and group number 14. So what we have not discussed. So before starting the p block element, I am going to discuss the some points from that particular group number 13 and 14, and then we will start this topic. So this particular topic consists the study of group 15 elements, then group 16 element, group 17 elements and group 18 elements. Not only just discussion of the families, or the not only just discussion of group in this topic. Along with that, we are going to learn about some molecules, or some of the compounds of elements from this particular p block. Okay. So from group 15 elements, we are going to learn about the dinitrogen, its preparation, its chemical reactions, its chemical properties, and its physical properties. Here we are going to learn another one important point, that is abnormal behavior of nitrogen. Why nitrogen is abnormally or anomalously showing different properties from the group 15 elements, that we are going to learn over here. Then we are going to learn a molecule of nitrogen, which is known as ammonium, that is NH3. The preparation of ammonium and the chemical properties and physical properties of ammonium we are going to learn over here. Along with that, we are going to learn about the oxides of nitrogen. Then we are going to learn about the preparation of nitric acid and its chemical and physical properties. Then we are going to group from group 15 only. We are going to learn about the another one element, what is called as phosphorus, the second element. In that phosphorus, we are going to learn about its allotropic forms: white phosphorus, black phosphorus, and red phosphorus. We are going to learn over here. Then we are going to learn about the phosphine, the preparation and its chemical properties. Then phosphorus halide, the phosphorus pentachloride and phosphorus trichloride. We are going to learn over here the preparations and the physical and chemical properties. And oxides or oxyacids of phosphorus, the structure and its basicity we are going to learn over here. So from the group 15 we are going to learn two elements, that one is nitrogen and its compound and phosphorus and its compound. In the group 16 we are going to learn about the electronic configuration and the physical properties of group 16 elements. Along with that, we are going to learn about the dioxygen, oxygen, the preparation of oxygen, the chemical properties of oxygen, simple oxides, then ozone. We are going to learn in this particular uh, group. Then from the same group we are going to discuss the second element, that is called as sulfur. Sulfur, its allotropic forms, then sulfur dioxide, preparation, chemical properties, oxoacids of sulfur, and sulfuric acid. So in oxoacids we are going to learn about the basicity of these oxoacids, the structure of oxoacids. Sulfuric acid, in that particular point we are going to learn about the contact process for the preparation of sulfuric acid, then the chemical properties, physical and chemical properties of sulfuric acid, the structure of sulfuric acid we are going to learn over here. Then the next group from this topic, that is group 17, and in this group 17 or halogens we are going to learn about the electronic configuration, physical properties of uh, halogen family. Then one of the molecule, which is what we are going to learn as a chlorine, its preparation, chemical properties, hydrogen chloride, that is called as HCl. So that particular HCl we are going to learn about the preparation and chemical properties of HCl, oxoacids of halogen, and interhalogen compounds. So in the halogens forms the compounds with each other, that we are going to learn what kind of compounds they are going to form, how they are going to form, and why particular compound is formed, that we are going to learn over here. And the group 18 elements, its electronic configuration, then physical and chemical properties, then some compounds of xenon we are going to learn over here. Apart from this, we are going to learn about what I have discussed in the group 15, anomalous properties of nitrogen, then in group 16 anomalous properties of oxygen, in group 17 the anomalous properties of chlorine we are going to learn in this topic. The next topic from this particular part, first, it is the D and F block element. So we are going to learn about the position of D and F block elements in the periodic table, the electronic configuration of D block elements, the different series present in the D block element and F block element, the general properties of D block elements, then important compounds of D block elements. Some important compounds of transition elements. In here we are going to learn about the two compounds. One is potassium dichromate and another one is
potassium permanganate. So the preparation of potassium dichromate, the preparation of potassium permanganate, and the chemical properties of potassium dichromate and permanganate we are going to learn over here. Then from A block element we are going to discuss the detail of lanthanide and actinide series. So 2 points are there, the lanthanide series and the actinides. So here we are going to learn about their electronic configuration, their chemical and physical properties, and then finally in this topic we are going to learn about some application of D and A block elements. Then the next topic from the part first, it's coordination chemistry. So coordination in the coordination chemistry or in the coordination compounds, we are going to learn about what is mean by coordination compound, what is the difference between the coordination compounds and normal salts, what is the difference between coordination compounds and double salts, we are going to learn. Then we are going to learn about the Werner's theory of coordination compounds. The Werner who has discovered this type of compounds, and he described the structures, the bonding of the coordination compound. So we are going to learn about that theory. Then very important point from the coordination chemistry, the definition, the important definition or the terms which are used in the coordination chemistry or coordination compounds. We are going to learn about the ligands, the coordination entity, the counter ion, the coordination number, the oxidation number. So all that we are going to learn in this point particular. Then we are going to learn about the nomenclature of coordination compound, and another one point, that is the structure and the representation or the molecular formula representation of our coordination compounds we are going to learn over here. Then this coordination compound shows isomerism, the same molecular formula for different structure formula, that is what we called as isomer. So the isomerism is possible in coordination compounds. So what kind of isomerism is possible? The optical and geometrical isomerism we are going to learn in this particular point, and which type of compound shows which type of isomerism, that we are going to learn in the isomerism part. Then we are going to learn about the bonding in coordination compounds, what kind of bonds are formed between a metal and a ligand, what we are going to learn over here. So in the bonding we are going to learn about the two theories, one is valence bond theory and another one is crystal field theory. So these two theories describe the bonding of coordination compounds, and they has different postulates. So we are going to learn that postulates and how the theories are explaining the coordination compounds, that we are complete in this particular point. Then the next point from this topic is metal carbonyls or carbonyl complexes. So we are going to learn about the how carbonyl ligand bind with metal, how they are formed, how metal carbonyls are formed, what kind of bonding is there, that we are going to learn in this particular point. And finally we are going to learn about the application of coordination compounds. So we are learning the coordination compounds or coordination chemistry, what kind of complexes, what kind of compounds are, where they are used, what is the requirement formation of this coordination compound, that we are going to learn in this last point, importance and application. Then the next chapter or the first chapter for the part first. Now the inorganic part is completed with that four topics: the general principle and isolation, the P block, the D block, and the coordination compound. These four topics are coming from the inorganic chemistry part. Now it's organic chemistry, and the second part, the book of chemistry, the second book of chemistry, which consists all the 7 topics from the organic chemistry only. So the first topic is haloalkane and haloarenes. So these are the compounds of carbon compounds which consist halogen. They are called as haloalkanes and haloaryls. So we are going to learn about the definition of classification of haloalkanes, then the nomenclature of haloalkane, then nature of carbon halogen bond, what kind of bond or how the bond is, that we are going to learn. Then the physical and chemical properties of haloalkane and haloalkane we are going to learn. We are going to learn about the mechanism of substitution reactions. So in this particular point we are going to learn about the mechanism of nucleophilic substitution reactions. Then we are going to learn about the optical isomerism, the, the chirality, the asymmetric carbon atom, the chiral center, the enantiomer, the diastereomer. That points we will cover in this optical isomerism part. Then we are going to learn about the haloarenes, its definition, its classification, the nature of bond between carbon and halogen in case of haloarenes, and the substitution reactions in case of haloarenes. Here we are going to learn about the electrophilic substitution reaction, and then we finally we going to learn about the environmental effects of these halo compounds, or the adverse effect of these compounds on the environment. We are going to learn and their uses, where they are used actually, that we are going to learn in this particular chapter. Then the next chapter is alcohol, phenols and ethers. So in alcohol, phenol and ethers, this particular topic, or in the particular organic chemistry part, whatever we are saying the functional group, we have to learn the certain common points. That is, we are going to learn about the classification, we are going to learn about the nomenclature, then the method of preparation, physical and chemical properties, mechanism of some reactions. These are the some common points in all these topics. So here also we are going to learn about the classification, nomenclature of alcohols, methods of preparation of alcohols, physical and chemical properties of alcohol, mechanism of dehydration reaction, uses of methanol and ethanol. Then in the phenol also we are going to learn the same point: classification and nomenclature of phenol, method of preparation of phenol, physical and chemical properties of phenol, acidic nature of phenol, why phenols are more acidic than alcohols, that we are going to learn over there. Then electrophilic substitution reactions for the phenols, and finally the applications of phenol, uses of phenol, where they are used. And the third category for this particular functional group, that is oxygen functional, ether. In ether also we are going to learn about the classification and nomenclature of ether, method of preparation of ether, physical and chemical properties of ethers, and uses of ethers, that we are going to learn over here. The next topic, what it called as aldehyde, ketone and carboxylic acid. In this particular topic we are going to learn about the nomenclature of aldehydes and ketones, the nature of carbonyl group, the structure of carbonyl group. So these all three are carbonyl functional compounds. Okay, so here the carbon is doubly bonded with oxygen, and all these three kind of compounds. So we are going to learn about that nature of bonding with carbon and oxygen. Then the method of preparation of aldehydes and ketone, physical and chemical properties of aldehyde ketones, nucleophilic mechanism of nucleophilic addition reaction. Here we are going to learn, in particular, the addition of HCN is there, that we are going to learn with the mechanism. Then the reactivity of alpha hydrogen in aldehydes. So what is alpha hydrogen atom, and what kind of reactions are given by aldehyde when there is alpha hydrogen atom, and what kind of reactions are obtained when there is absence of alpha hydrogen atom, that we are going to learn over here. Then the uses of aldehydes and ketones is there. In the carboxylic also we are going to learn about the nomenclature of carboxylic acid, the acidic nature of carboxylic acid, how the acidity of carboxylic acid changes with presence of certain groups, then method of preparation of carboxylic acid, then physical and chemical properties of carboxylic acid and uses of carboxylic acid, what we are going to learn over here. And the next topic is compounds containing nitrogen or nitrogen containing compounds. We are going to discuss in this particular chapter, we are going to discuss about the nitro compounds, NO2 group containing compounds, then amines, the NH2, NH, or just N, which is triply substituted by alkyl groups, what we are called as amine, that we are going to learn over here. Diazonium salt we are going to learn over. So all the three category of compounds, that is nitro compound, amines, and diazonium salt, we are going to discuss about their nomenclature, their classification, physical and chemical properties, method of preparations, and we are going to learn about the basicity of amines. So here we are going to discuss about how the amines are more basic than ammonia, what is basicity between the aromatic and aliphatic amines. That part we are going to discuss over here. Along with that, we are going to discuss certain application of this nitrogen containing compounds. Next chapter from this part, second, it's a biomolecule. So whatever we are learning in the biology, some molecules or some compounds we are learning in the biological system, that we are going to discuss in the chemistry also. So here we are going to discuss about the carbohydrates, its classification, the monosaccharides, its configuration, DNL configuration, then oligosaccharides, polysaccharides, and their representation, the structure representation. There is a Fisher formula for the representation of carbohydrate structure. There is a Haworth formula for the representation of these particular carbohydrates, the linkages, the importance of carbohydrates we are going to learn over here. Then we are going to learn about the protein. In this particular chapter, we are going to learn about the protein, the elementary idea of amino acid, peptide bond, protein, and structure of protein. Then enzyme, hormones, vitamins, classification, and the deficiency diseases of vitamins, the function of vitamins. Then finally nucleic acid, we are going to learn about the nucleic acid, DNA and RNA, and the different kind of base present in the DNA and RNA, their structures, their linkages, what we are going to learn in this particular topic, what is called as a biomolecule. So we are going to cover in this particular chapter, we are going to cover the carbohydrates, proteins, vitamins, hormones, enzymes, and nucleic acids. The next topic which is come from the polymer chemistry, and the name of topic is polymer. And in this particular topic we are going to learn about the classification of polymer, the method of polymerization. So there are two different methods for polymerization: addition polymerization and condensation polymerization, that we are going to learn about that. Copolymerization we are going to learn. We are going to learn about the certain preparations of certain polymers like polythene, nylon, polyester, bakelite, rubber, biodegradable polymers. So that we are going to learn along with their applications where they are applied, that we are going to learn in this particular topic. So this is 5 marks weightage topic, which question comes in the last question number 5. Okay, so we are going to learn the polymers, the plastic, the synthetic polymers, the cloth what we are using, the rubber what we are using, that we are going to learn how they are prepared, what is the method of preparation, what are the monomers required, that all part we are going to learn in this particular topic. And finally, the last topic from the chemistry syllabus or chemistry subject, it's a chemistry of everyday life. In this particular topic, we are going to learn about the chemicals in the medicine, which is called as a drug. Okay, so we are going to learn about the drugs, and we are going to learn about the different kinds of drugs, that is like analgesic, tranquilizer, antiseptic, disinfectant, antimicrobial, antifertility, antibiotic, then antacids, antihistamines, all these kind of drugs and their examples. What we are going to learn, their structure and examples of these kind of drugs, the different types of drugs. Then chemicals in food. So we are using the food colors, food preservatives, artificial sweeteners, antioxidant, that we are going to learn about in this particular point, that is chemical in food. What is preservative, artificial sweetener, antioxidant, that we are going to learn over here. And finally, in this topic, we are going to learn about the cleaning agents. So on the daily basis, what we are using soap and detergents for the cleaning of our body or our clothes or uh, what it is, floors. So what kind of chemicals are used for the preparation of this soap and detergents, that we are going to learn. Then we are going to learn about the cleaning action of soap and detergent. What actually the process, or what actually the mechanism of soap, how they clean the surfaces, how they clean the clothes, that we are going to learn in this particular point, that is called as cleaning action. Okay, so here we are going to learn about the chemistry, which is we are using in the daily life or everyday life. So chemicals what we are using in the daily life, that we are going to learn in this particular topic. So this is regarding the syllabus of chemistry. So there are total 16 topic as per the 100% syllabus. So we will discuss one by one from the next lecture onwards. So hope that you have clear regarding the what is syllabus you have in the PUC second. So you have to go through this syllabus, um, correctly check out the topics, the weightage of topics where the question is asked, and along with that start the textbook reading, which is very helpful for the competitive examinations and which will help you for the online studies also. So now there is a question that you don't have a second year book. So there is certain online uh, sources which gives you a PDF format book, second year NCERT book, class 12 book, or there is certain apps which you can download, from which you can download the book for all subject: chemistry, mathematics, biology, physics, English, Hindi, all that. So go to that particular site, or you download the certain applications in your mobile, so you will get the soft copy of the book. Okay, so from next lecture onwards we will start the actual syllabus. Once again, welcome you all to PUC second, and thank you for listening me.